In this video, we are going to look at how you calculate the energy produced when burning fuels. Different fuels release different quantities of heat energy per gram of fuel burned. To calculate this, we use the following formula. Where E stands for the energy released in the reaction, and this is in kilojoules. C is the specific heat capacity of water, and you will find this value in your data booklet. It is 4.18 kilojoules per kilogram per degree. M stands for the mass of water in kilograms, and delta T is the change in temperature in degrees. For these calculations, we must keep in mind that 1 centimetre cubed of water is equivalent to 1 gram of water. Therefore, when we're working out the mass of water in kilograms, if we are given a volume in centimetres cubed, we must divide that by 1,000 to get our mass in kilograms. Now let us look at some examples of these questions. Example 1. When a sample of methane was burned, the heat produced raised the temperature of 100 centimetre cubes of water from 20.2 degrees centigrade to 29.3 degrees centigrade. Calculate the heat energy released by this reaction. The first thing you should do is to write down your formula. We can then go through the question and tick off the information when we get to it. The first piece of information we are given is 100 centimetres cubed, so our mass of water. As previously stated, the volume is related directly to the mass, so we have to divide by 1,000 to get the mass in kilograms. So our value here is 0.1 kilograms of water. We then read on and realise that we have our delta T, our change in temperature as well. So the reaction started at 20.2 degrees and it finished at 29.3. So it's just a simple subtraction here. And we find that our change in temperature was 9.1 degrees centigrade. We can then fit this information into our formula. C, as always, is 4.18. We times that by 0.1 times by 9.1, and when you multiply that, you work it out to be 3.8038, and with rounding we find that the energy released by methane was 3.8 kilojoules. Let's look at another example. Methanol was burned in a spirit burner and raised the temperature of 800 centimetres cubed of water from 20 degrees to 85 degrees. Calculate the heat energy released. Again, we write down our formula and we go through the question and we tick the piece of information off. For mass, it's 800 centimetres cubed of water divided by 1,000 to give us a mass of 0.8 kilograms. And our change in temperature is 85 degrees centigrade minus 20 degrees centigrade. So we get a value of 65 degrees centigrade for our temperature change. Substituting that into our formula, we have 4.18 times 0.8 times 65, and that gives us an answer of 217.36. And we'll round that to 217.4 kilojoules. So far we have looked at straightforward examples of calculating the energy produced when burning fuels. However, sometimes they want you to manipulate the formula and instead work out the temperature change or the mass of water during the reaction. Here we have a more complicated example. What is the temperature increase when butane is burned, releasing 125.4 kilojoules of heat energy that is used to heat 1,500 centimetres cubed of water? Again, our first step must be writing down our formula. Except this time we have to manipulate our formula. So this time we're interested in delta T. So we have delta T equals energy released over Cm. Energy released comes straight from the question. So we can substitute that figure in, 125.4 kilojoules. The specific heat capacity of water we know to be 4.18. And all we need to do is work out the mass of water used. We have the volume of water is 1,500 centimetres cubed. We divide that by 1,000 to work out the mass in kilograms. And we find that we use 1.5 kilograms of water in this reaction. When you calculate this, you get 6.27, and altogether when you do that division you will find that it is 20. Therefore the temperature increase during this experiment is 20 degrees centigrade. You must be able to manipulate these formulas. In your data booklet you are given this formula as is, however you need to know how to change it to work out the specific heat capacity, the mass, or the temperature change if required.